This is one of those moments where science gets genuinely mind-bending. Researchers in Australia have managed to capture something that quantum theory has predicted for decades, but until now, no one had actually seen it happen with real matter. They worked with helium atoms and showed that these particles can exist in two different places at the same time, not just in theory, but in a way they could directly observe. To make this happen, the team cooled a cloud of helium atoms to temperatures just above absolute zero. At that point, the atoms slow down so much that they stop behaving like tiny solid particles and start acting more like waves that can overlap. When the researchers released this cloud from a magnetic trap, two groups of atoms collided head-on, creating the perfect setup for something unusual. From that collision, pairs of atoms shot out in opposite directions. And here's the strange part. Measuring one atom moving one way instantly tells you its partner is moving the other way, no matter how far apart they are. To really prove what was going on, the scientists pushed things further. They used laser pulses like a kind of beam splitter, sending each atom along two different paths at the same time. After that, the atoms were allowed to fall, and detectors recorded where they ended up. What they found was an interference pattern that could only mean one thing. Each atom had actually traveled both paths simultaneously until the moment it was measured. One atom might show up on one side, its partner on the other, but the data made it clear they had both been exploring both possibilities the whole time. What makes this especially important is that these aren't particles of light. Earlier experiments like this used photons, which don't have mass and aren't affected by gravity. Helium atoms, on the other hand, are much heavier and behave like real physical matter we can relate to. And yet, they still show this bizarre quantum behavior. The results even passed a major test known as Bell's inequality, which basically rules out any normal classical explanation. In simple terms, measuring one atom instantly determines the state of its partner, no matter the distance between them. It's exactly what quantum theory has always suggested, but seeing it happen with actual matter takes things to a whole new level. This experiment doesn't just confirm a theory, it gives us a clearer glimpse into how the universe really works at its most fundamental level. And honestly, it's a lot stranger than anything we experience in everyday life.